Hello everyone, welcome to Homework Help. If you find the video useful, please subscribe to the channel. So in this video, we'll solve this problem using the concepts of optimization using derivatives. So as per the problem, a rectangle lies in the first quadrant with one vertex at the origin and two of the sides along the coordinate axes. If the fourth vertex lies on the line defined by x plus 2y minus 10 equals 0, find the rectangle with the maximum area. So the first step is to draw a diagram and show the rectangle in the first quadrant. Let's assume this is a rectangle and the coordinates of the fourth vertex are A and B. So that means the length of this rectangle is A and the width of this rectangle is B. Also, we are given that the point A comma B lies on the line x plus 2y minus 10 equals 0. So we can sub in the coordinates A and B in this equation to find a mathematical relationship between A and B. So we sub in x as A and y as B. We can isolate A in this equation, so we can move the 10 and 2b to the right side of the equation, and that will change the sign of the terms. So this is the expression for A. Now we have to find the rectangle with the maximum area. So let's start with the formula for area of a rectangle. It's equal to length times width. The length of this rectangle is A and the width is B. Now this area equation has two variables A and B, so we can do the substitution for A using the equation for A. So we can replace A with negative 2B plus 10. Now we can distribute the B into the parentheses. So I get negative 2B squared plus 10B. So this is the area of the rectangle in terms of B. Now we can find the domain for this area function. B represents the width of the rectangle and it's the y coordinate of a point in the first quadrant. So we know that B cannot be less than or equal to 0. So B has to be greater than 0. B will achieve its maximum value when A is 0 in the equation. So if we sub in A as 0 in the equation, we have to solve for B. So we should move 2B to the left side and that will make it positive. Now we can divide both sides by 2. I get B equals 5. But A cannot be equal to 0 because if A is 0, that means the length of the rectangle is 0. So that means the domain for this function is B is greater than 0 but less than 5. Next, we can find the derivative of the area function and set the derivative equal to 0 to find the B values at which the tangent is horizontal, because tangent is horizontal at maximum points in the function. So to find the derivative, we'll have to use the power rule. The negative 2 is the coefficient of the term, so it will stay as it is. And as per the power rule, the derivative of b square is 2b. In the second term, 10 is the coefficient, so it will stay as it is. And the derivative of b is 1. Now we can set the derivative equal to 0. And solve for b. So we should add 4b to both sides. Now we can divide both sides by 4. I get b equals 2.5. This b value lies in the domain, so that means it's a valid answer. Next, we have to find the area of the rectangle at the endpoints of the domain and at b equals 2.5 to find the b value at which the area is maximum. So let's start with b equals 0. So if we sub in b as 0 in this area equation, I get 0 as the area. Next, we can sub in b as 2.5 in the area equation. So I got 12.5. Next, we can sub in b as 5 in the area equation. I get 0. So that means the area is maximum at b equals 2.5. Next, we should find the value of a, and for that we can use this equation here. So we'll sub in b as 2.5 in this equation. I get a equals 5. That means the area of the rectangle will be maximum if the coordinates of the fourth point are 5, 2.5. So this should be the final answer for this problem. So these are the steps you have to keep in mind to solve a problem like this one. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.